So before we dive into questions, maybe we answer most of them with a small demonstration. I want to show you exactly from just a polyline in Rhino that would match the 3D space of some piping project, let's say. So my colleague Voya will help demonstrate this. So Voya, you can start. I will talk over it as you work.
Okay, thank you.
So hypothetically, this is some piping system. So first, you would of course draw out the polyline in 3D space how the actual pipes are supposed to be positioned, and then you can run the create pipe command. It should be pretty simple to use. You have a button here, select curve. You simply press it, and then you select the curve in Rhino, which you want to turn into a pipe. Here you can choose the diameters. You can define the wall thickness. Also, you can choose the radius of the elbow, depending on the bend you need. And you can choose the thickness of the wall of the elbow itself if you need a strong elbow. And then you can simply select create. And you will receive the geometry of a pipe. Pretty simple for now. And then let's say let's first end this part of the pipe. Let's add a flange. So you can select the face of the pipe you want to add the flange to, and then you can choose the type and simply press create. Yeah, let's do it on both sides. Okay. Same thing. We finish off the line, and then we can add some sleeves. So we have double and single sleeves. Currently, this is a double sleeve. You can define the parameters here for the exact double sleeve you wish to create. And then you can select the button create, and you have your double sleeve. The pipe is cut, and the double sleeve is applied to the position where you clicked. So we have some sleeves on this line. Now let's add some single sleeves. Well, if you can just show the interface for a second after you select. Okay, so here it's also pretty simple. You select the pipe, and after you select the pipe with left click, it will show the center line of the pipe, and you can go along the center line with your mouse, and you can select exactly which point you want to insert the sleeve. And then after you select that, you can choose if you want or not to split the pipe, and you can define the sleeve parameters, and then simply press create, and the sleeve is added according to what you chose. Okay, let's move on, Voyo. Let me just see. Okay. So now about organizing the model. So if we want to split this model into separate layers in Rhino, this is of course our way of organizing it. I'm assuming you have a different one, but the commands themselves can easily adapt. If I don't know if you had a chance to see, you had the option on create pipe interface. There was an option add to current layer, which should let you then simply select the layer in Rhino and start adding geometry into it. Here, Voya has basically split the elements we've created into 3 separate spools. And then once we have the line split into spools, we can start positioning the elements of the line. So you run the automatic positioner. You define the name that you want. So the prefix of the position.
Sorry, to split the spool, I make the line, then I create a pipe. I add the connection, the flange. Can I split the pool after I made the pipe and add some flange, for example?
Yes, that is not a problem. You only have to pay attention how you split things. So that will only come down to your organization of the layers. So if you want to, for example, we can insert a flange. Let's take a pipe. we can run the modify pipe command. If you take the pipe, the one that is between the two double sleeves that doesn't have sleeves on it, that should be easiest to demonstrate.
Okay.
You can go into, for example, top view and run the modify pipe command and select the one pipe we want. Yeah, like that. That should be good enough. And let's say we want to, somewhere on this line, you want to insert a flange. Select the most right point, Voya, and just cut the pipe to the left a little bit. So we delete the elbow and we shorten the pipe a bit. So yeah, just like that, that's fine. Confirm the command. And here, so you can cut off the line if you want, and you can add a flange and continue the other line somewhere else. Or we also have options to automatically merge lines. If you delete the flange wire, run auto path. It will attempt to find the shortest path. Of course, this is 3D space, so it can be this one worked perfectly. Okay. So here you get the point, right? So you can modify, you can play around with the line. You can cut it, add elements. You can automatically create paths between lines if you want to merge things. So it should give you enough freedom to basically model it exactly how you want.
Okay.
Okay. Let's continue then, Voya, with the positioning. So let's assume this line, actually now it's a system. We have three spools, and yeah. So we can assume this one is, let's say it's fine model-wise. Now we want to create the documentation for it. So first we do positioning of the elements. As we've already split them into layers, we will do positioning based on spools. So here, since the layers are, we did the command, you have to reassign them, Voya. There we are, okay. And we select. So the automatic position will basically ask you for a prefix, and it will ask you from which value you want to count up. Do you want to start from 0, from 1, or rather, do you want to start from 1, or do you want to start from 10, from 20, from 500? However you wish to define the positioning. So now that we have positioning done, let's continue. You want to show the export? Okay, we can go over that. Extract 2D. Okay, good. Yeah, this is what I wanted you to run. So we select the system layer. So that will be the layer that contains all the spools that we have created. And here you can play, this view will define how the 2D projection of the system is created. So you can play around, move the camera around to get the exact projection you want. And then per spool, you can select also, again, this perspective view where you will define the isometric curve, which will be created into documentation. And here you can choose the views you want for your documentation. So depending on which view shows the projection best, shows the elements best, you can choose. You simply press left click and you see the blue outline that it is selected. Once we have everything, we simply press accept. We let the command run. So here you see the bill of materials table. So each technical paper is generated with bill of materials table, directional symbol. You will see the orthogonic views you selected. So if it's top, if it's left, if it's whatever you selected from the menu, here you will see it. Leaders are automatically positioned, but they're not perfect, of course. But it's a simple command you can run called rotate. You have to ungroup first, Voya. I think I added grouping so you can move around easily. Or did you already ungroup? You already did. Okay, sorry. So we run rotate leader, and we simply select the leader we want to rotate, and we move it around. You have a small preview. Spin the mouse around, Voya. So you see you have a preview basically where the leader will be positioned. So you select the position you want, and it moves the leader there. So it's basically comes down to right click, left click, and just playing around and moving things around to better fit your needs. Besides the orthogonal projection, we have the isometric projection. This is the perspective view of the spools I was talking about. Here we can go through quickly, set up the leaders how we want them to be. And we can repeat this process and basically play with the technical papers generated how we want. So this is the intent of this is to give you the basic information you need that also the people at the shipyard can understand. You will see the bill of materials. You will get the projections you need for the welders and for everybody else working at the shipyard, so they understand where they actually have to place this line or this spool rather. But we also left, for example, the convention at the bottom right of the paper. We didn't place anything. I avoided adding that because everybody has their own convention, you know, how they place the signatures, the project name, project type, etc., etc. So I didn't want to constrain people. So you can, once you export this to CAD if you want, or however you use this, you can simply add it. I'm sure you have some sort of template.
Yeah.
Okay, so this is basically that process that we mentioned, that we talked about at the beginning, so that you can model out a pipeline, you can assign the positioning, and you can generate basically CAD-ready drawings directly within Rhino. Now, Voya wants to see what we didn't position. I think we probably missed one element here or there. But besides this, we've shown you how basically what the purpose of the software is. So you receive the plan for the pipeline, you receive the ship general assembly, etc., and you know exactly how you need to model it in Rhino. And then you can use this software to basically make the whole process a lot simpler. Now, the values you saw for, let's check, do we have something? Now it's good. Now if we rerun the command, it shouldn't complain anymore. But besides this, as you saw, at the bottom right of the Rhino viewport, you saw a little red error message. That's the convention for all commands. So if something is missing, if something is incorrectly placed, etc., etc. So any issues that command may run into, it will tell you right there. So if some position is missing, if some material is missing, there we go. And now we also have the system projection. Now you can, of course, ungroup this, modify this.